I'm here with Christophe Cugge from Ampleon at the Microwave show in Madrid. Christophe, can you explain us what is Ampleon showing here at this Microwave show?
Yeah, good morning, welcome to Ampleon. So what I'm going to show you is actually the solutions we developed for the mobile broadband market, which is basically the infrastructure for cellular networks.
Okay.
Yeah? So we have products for 4G, which is what is mainstream now, and also 5G.
5G products are also in development.
Yes.
Yeah. Is there a huge difference between developing for 4G and 5G? How does that relate to each other?
Yeah, 5G is introducing a new technique called massive MIMO, and this uses a large number of antennas in each sector to enable to focus a beam towards each handset. So that makes a much more complex base station, and for us that means many more PAs per sector.
Yeah.
In 4G went up to maybe 8 PAs per sector. With 5G, we're talking about 64 PAs per sector.
Okay.
The power level of each PA is smaller, but the requirements on cost and efficiency is much more stringent than it used to be.
And the technology always go in the base stations for the new 5G technology.
Yes, we are moving slowly from just transistors to completely integrated amplifiers.
Okay.
Yeah, so due to the growing number of antennas, we are going towards more integration. So at first we integrated the two transistors, which enable to make a Doherty in one package.
Yeah.
That was the first step, started already 10 years ago. The next step was to integrate the splitter and the combiner. And now we are looking at multiple stages, splitter, combiner, so it's indeed a complete PA, which is in one package.
You are in a very specific area. You are pushing electronics to the limit.
Yes.
You have high power, high frequencies. How difficult is that from a design point of view?
It's in fact very easy if you don't care about the other important parameters, which are cost, efficiency. Yeah. So we have to increase power, we have to increase the performance at high frequencies, but still keep the same cost.
Yeah.
And this is the main challenge we have, because in RF, everything is compromise, and it's very hard to increase just one parameter without reducing performance in one other parameter, linearity, size of a solution. So everything has to be improved at the same time.
Yeah.
This is why we like to use technologies such as LDMOS, which have a very low cost of integration. So using GaN enables higher performance, but it doesn't enable to integrate a lot of functionality on one die, because the cost is prohibitive. Thanks to LDMOS, we can actually have multiple stages, multiple transistors. We can have a splitter, a combiner matching to 50 ohm, all of that on one die.
Yeah.
And that enables to make very, very compact and cost-effective solutions.
Okay.
And generation after generation, we managed to push up the limit, the envelope of technology. So I think about 10 years ago, we were the only company doing, at the time it was NXP, which became Ampleon. We were the only company doing or using LDMOS for WiMAX at 3.5 gigahertz.
Yeah.
And now it's widely used for 5G. So it has, for us, WiMAX has driven the development of higher performance at high frequencies.
Yeah.
And that's been for us always one area of leadership.
Yeah.
It's to basically tweak the technology to go up to higher and higher and higher frequencies.
Yeah.
The next generation, we are planning to go up to 5 gigahertz.
Yeah.
And we're already looking at how to go up to 7 gigahertz with LDMOS. Yeah.
Really, again, pushing the limits of electronics.
Yes. So this is a PA for 1.8 gigahertz, which is the most popular band in 4G actually. It's called band 3, and it's the most widely used. Until this generation of product, we could integrate up to 60 watts. That's the average at the antenna. Up to 60 watts in one package. This is a fully integrated PA for 5G for quite a high frequency, 3.5 gigahertz. And this little package is 8 by 8 millimeter, very low-cost plastic package, QFN, that integrates 3 stages of amplification, a Doherty splitter and a Doherty combiner. This is something that used to be using about 4 times more board space when it was not integrated.